Hi, I'm going to begin our first exam review with a compound inequality problem. And you can see that I've rewritten these two sentences down below so that I can work them easier. When you're solving compound inequalities, you just simply have to solve each inequality separately and then put both answers on the number line. So these are done much like equations where you're going to isolate the variable. So I'm going to start by subtracting 9 from both sides. And as I do, you get negative 11m is less than 33. Now I'm going to divide by negative 11. The other thing you need to remember when working inequalities is that when you do multiply or divide by a negative, you've got to flip the symbol over to maintain the inequality's correctness. So that's going to equal m is greater than negative 3. And this one over here is fairly easy. You're just going to subtract 2 from both sides. No need to flip that symbol over because we did not divide by a negative. And now we're going to take these two answers and place them on the same number line. Numbers that are greater than negative 3. Well, I'm going to find negative 3 on the number line. I'm going to put a hollow circle around it because, as you can see, negative 3 itself is not a part of this solution set. So numbers that are larger than negative 3 go to the right, and then find negative 10 and put a hollow circle around this one because negative 10 is included in the solution set. You see that little bar right there means less than or equal to. So we want to make sure 10 gets put in the solution set. And numbers that are less than negative 10 go here to the left. Okay, move on to number 2. Again, it is a inequality question, and it involves absolute values. With absolute value inequalities, we do have to write two sentences, as you've seen here. The first sentence, you just remove the absolute value symbols and you just solve it at face value. The second one is the only thing that changes here is this symbol flips and you negate the 27. You do not change anything in this part of the equation. Okay, so again, we're going to start by isolating the variable, and I'm going to start by subtracting 5 from both sides. Don't drop that negative, a very common mistake. And when you subtract these two, you get 22. And I'm going to divide by a negative. And again, when you divide by a negative, you've got to flip that symbol over. And I'm just going to, let's reduce this down to negative 11 over 4, which does equal negative 2 3/4. We'll come back to that later. And again, we're going to do the same exact thing over to this equation. The answer will be slightly different because of this symbol flip and negation. So I'm going to get negative 8p is greater than, preceding signs are the same, so we're going to add those together. That gives me negative 32. Next, I'm going to divide by negative 8, just like I did in the previous. And again, when you divide by a negative, you're going to flip the symbol over, and a negative divided by a negative is going to make that a positive 4. Now I'm going to put both of these on the same number line. Numbers that are less than 4, let's start with that one. Since it's not included, it will be a hollow circle around the 4, and I'm going to go to the left, and I'm not going to go all the way yet because sometimes these overlap, as in this case. P is greater than negative 2 3/4. Well, there's negative 2, and let's just estimate 3/4 down the line is right about there. And again, it's a hollow circle. Numbers greater than negative 2 3/4 are going to go to the right. So our solution set is actually an intersection of the graph in between those two endpoints. And so there is the answer to question number 2. Let's move on to 3. Oh, great, an absolute value graph. This time, again, we want to remember that an absolute value graph takes on the shape of a V. First thing you need to do is find the vertex. And you can do that by setting the absolute value part equal to 0 and solving. So I'm going to add 3 to both sides. And I get x is equal to 3. And that gives me my x coordinate of my graph. To find the y coordinate, I'm going to go up here and I'm going to run that 3 through this equation. So 3 minus 3 is 0, and 0 plus 4 is 4. So y is equal to 4. And so my ordered pair is going to be 3, 4, and that is the vertex. So I'm going to come down here, find 3, go up 4, and now I'm going to graph the branches of this. Now this can be done several ways. You can build a table of values, or you can take a look at this, and you notice it has a slope of 1. And that simply means that I can go up 1, over 1, up 1, and over 1. So there's going to be one branch. The other branch is the reflection part, so it will be over here. And you can do it just that quickly. There's no need to make a big deal out of it. It can just be done just like that. Again, a table of values would have also gotten you these same exact points. Another thing I want to point out here is, if you remember that when we did quadratics, the number inside the parentheses at the time, you take the opposite of, and then the second number at face value. And if you notice that, that really has the same pattern here. If you take the opposite of -3, you get +3, and you can see that's what we got here, and then the 4 at face value. So I just wanted to point that out. Number 4, we're going to graph these two inequalities, and then the overlapping region will be the solution set. So let's just look at it. We're in the y equals mx plus b. I'm going to plot my y-intercept at 3. That's this point right here. This is the slope, -1/2, so I need to make sure I go in one negative direction. If I go up, that's positive, then I must go back because that's negative. Or I can drop down 1, go forward 2, drop down 1, go forward 2, and repeat that pattern. This particular boundary line is going to be dotted because it is not included in the solution set. Now I want to run a test point. I need to see which half plane the solutions lie in. So I'm going to use 0, 0 as my test point. And I'm just going to plug 0 in for x and y. And then I'm going to see if that sentence came out true or false. And as we go through this, we get 0 is greater than, well, half of 0 is 0, plus 3 is 3. And 0 is by no means greater than 3, so that is going to produce a false sentence, which means that this is the false half plane, and this side over here is the true. I'm going to do a fence row of t's for right now because I need to remember that I'm going to only be shading in the overlapping region. Next, I'm going to take a look at this, and I'm going to do the same exact thing. I think I'm going to change my color out here so we can see the two lines a little bit better. And this y-intercept is going to be at -2, and it has a slope of +2, so I'm going to rise 2, run 1, rise 2, run 1, rise 2, run 1, and it has a boundary line that is solid. So I can go over here and do a solid boundary line. And now I want to again test the points out. So I'm going to take the 0, 0, and I'm going to run it through. Whoops, let's erase that. I'm going to run it through this equation is less than or equal to 2 times 0 minus 2. And that yields a sentence that is also false. 0 is not less than or equal to -2. So again, here we are false, and that's with respect to this boundary line. So my fence row of t's are going to be over here on this side. And what I'm looking for is the area where I have both green and pink t's, and you can see that it is going to be in this region right here. So you want to just shade that in real good so that it's obvious that that is the solution set. One more question, and this one is solved by elimination. You'll notice I've already kind of got it started for us. We want to match up the variables. We need those twins to go with this problem, and so I thought the easiest thing to do would be match up the x's. And in the meantime, I would also want to make sure that they're opposites of each other. And so since these have the same signs, I ran a -4 through this sentence, and this is what the end result of that was. Now you can see that the x's are matching opposites, and they will cancel out nicely when you add these two together. And when you add the y's together, you're going to get 23y is equal to 69. I'm going to divide by 23. Divide by 23, and we get y is equal to 3. And I'm not done. That's only half the answer. So what I need to do is take that 3 and replace it in for y. And it doesn't matter which one of these sentences you choose. I'm just arbitrarily choosing the second sentence. I'm going to take out the y, plug in the 3, and I'm going to solve this. And I'm going to add 21 to both sides. and I get negative 2x. The 21's cancel out, and I'm going to get 22x. Negative 2x is equal to 8. Divide by negative 2. X is equal to negative 4. And so my ordered pair is going to be negative 4. You want to put the x value first, positive 3. And that concludes this video.